Hello friends, welcome to video lecture on kinematics of machinery. In the today's session, we will learn about kinematic chains, types of joints and mechanism. So let us start kinematic chain. When the kinematic pairs are coupled in such a way that the last link is joined the first link to transmit definite motion, that is completely or successfully constrained motion. It is called a kinematic chain. In other words, a kinematic chain may be defined as a combination of kinematic pairs joined in such a way that each link form a part of two pairs and the relative motion between the links or elements is completely or successfully constrained. So as per the definition one for the kinematic chain, so kinematic pairs are coupled in a such a way that the last link is joined to the first link to transmit the definite motion. Okay, it is called kinematic chain. Now if you look towards this one, the combination of kinematic pair, so just see the various links. This one, the frame indicate the link number 1, this indicate the link number 2, this indicate the link number 3. Apart from this one, the link number 4 is nothing but here cross head, and this one total this cylinder. Okay, this indicate the link number, this one cross head means here that connected with the piston rod. Okay, this one is nothing but the link number 4, and again the cylinder is nothing but the fixed one that is connected with the frame. Okay, so the whatever the link number 1 is nothing but that will form one crank with the fixed link. Okay, this is the link number 1. Then this will form a pair number 1. Okay, so link number 2 with the link number 3 is the crank with the connecting rod, that will form a pair number 2. With the next one, link number 4. Okay, link number 4 is here piston. Okay, and piston with the cylinder or frame, okay, is nothing but the next link. Okay, say every link form a combination with the other link. Okay, so this is known as kinematic chain. Okay, so already I discussed about the link. Link is nothing but the each part of the machine which moves with the some other part, that is known as link. What's about the pair? Pair is nothing but the combination of the two links. When the two links are connected with each other, okay, that is known as kinematic pair. And what's about the chain? Chain is nothing but the combination of kinematic pairs. Okay, such way that each link, if you focus on this link form a part of two pairs. Okay, so one pair is here, other pair is here. If you consider this one, this link form a part of two pairs. Okay, pair form because of this link with this one and this link with this one. Okay, so this is known as kinematic chain. Now in this case, if each link is assumed to form a two pairs with the two adjacent links, then the relation between the number of pairs p forming a kinematic chain and the number of links L may be expressed in the form of an equation L equals to 2p minus 4. Okay, where this L is nothing but the number of links, indicate the number of pairs. Okay, so equation number 1 with us. Since the kinematic chain, each link form a part of two pairs, therefore there will be as many links as the number of pairs. Another relation between the number of links and the number of joints which constitute a kinematic chain given by the expression J equals to by 2 into L minus 2. Okay, nothing but the equation number 2. So the equations 1 and 2 are applicable only to kinematic chains in which lower pairs are used. These equations may also be applied to kinematic chains in which higher pairs are used. In that case, each higher pair may be taken as equivalent to two lower pairs with an additional element or link. Okay, so let us apply the above equations to the following cases to determine whether each of them is kinematic chain or not. Let us consider the arrangement of three links AB, BC and CA with pin joints at A, B and C as shown in figure. So in this case, how many number of links? Just count 1, 2, 3. Okay, so small l with us 3. So what's about the number of pairs? Here the pair between 1 and 2, first one, 2 and 3, second one, 3 and 1, third one. So number of pairs with us 3. Number of joints, let's count 1, 2 and 3. So 3 joints with us. Now from equation number 1, so equation number 1 is here, L equals to 2p minus 4. Okay, from this relation, what's about the L? As far as concerned with this arrangement, the number of links with us 3. Okay, what's about the number of pairs? Number of pairs with us 3. Okay, so substitute the value of for this one L. Okay, and just solve this one. What do we get here? 3 equals to 2. Not possible. Here in this case, LHS side becomes greater than the RHS side. Now from equation number 2, here is the second relation with us. J equals to 3 by 2 into L minus 2. Just apply this equation. So in this case, if you look to us here, J equals to 3 by 2 to L minus 2. So what's about the J? Already we know the value for the J equals to 3. What's about the L? 3 with us. Just substitute to this equation. Again, if you just see this relation with us, 3 equals to 2.5. This is not possible. In this case also, LHS is greater than RHS. Since the arrangement of the three things as shown in figure does not satisfy equation number 1 as well as equation number 2. So in both the cases, LHS is greater than the RHS. Okay, so therefore it is not a kinematic chain and hence no relative motion is possible. Such type of the chain is called block chain and forms a rigid frame or structure which is used in bridges and trusses. Next one, consider the arrangement of four links AB, here AB, BC, CD and AD. Okay, as shown in this figure. Okay, so in this case, what's about the number of links? Just count the number of links: 1, 2, 3, 4. So number of links with us 4. Number of pairs, number of pair here, the link 1 and 2 form pair number 1, 2 with the 3 second, 3 with the 4 next and 4 with the 1 next. So number of pairs with us 4. What's about the number of joints? Count them: 1, 2, 3, 4. So 4 joints with us. Okay, now just from equation number 1, L equals to 2p minus 4, substitute the value of L here. Okay, so what's about the value for the P? 4 with us, substitute here. Now if you look towards this relation, 4 equals to 4. Okay, now here LHS side and RHS side, okay, both the sides are same. Now from equation number second, J equals to 3 by 2 into L minus 2. So in this case, just substitute the value for J. Here substitute the value of L. Okay, so in this case also we can get 4 equals to 4. Okay, LHS equals to RHS. Since the arrangement of 4 links as shown in figure satisfies both the equations, equation number 1 and equation number 2, it is known as kinematic chain of 1 degree of freedom. So the concept of this degrees of freedom we'll discuss in the next or coming part. So before that, just here, a chain in which a single link, here AD link with us, okay, is sufficient to define the position of all the other links. It is called kinematic chain of 1 degree of freedom. Okay, so if a definite displacement, say theta, is given, link this one AD, keeping the link this one AB fixed, then the resulting displacement of the remaining two links, that is BC and CD are also perfectly definite. Thus, we see that in a 4-bar chain, the relative motion is completely constrained. Hence, it may be called as constrained kinematic chain, and it is the basis of all the machines. So already I have seen the meaning of constrained chain, completely constrained chain, incompletely constrained chain, and successfully constrained chain. So here, as far as concerned with this one, kinematic chain, constrained kinematic chain. So here, the motion of this link takes place in definite direction. That is the case of completely constrained motion. Already you have seen that part in the previous lecture. So in case of incompletely constrained motion takes place more than one direction. Okay. So let us see the next case. Consider an arrangement of the 5 links. Okay, in this way. Now just count the number of links: 1, 2, 4, and 5. Just see the number of pairs. Pair between link number 1 and 2, first pair; 2 and 3, second pair; 3 and 4, third pair; 4 and 5, fourth pair; and 5 and 1, fifth pair. Okay, so you can get the equals to 5. Similarly, number of joints, just focus on here. Okay, so here's the first joint with us: 1, 2, 3, 4, 5. So apply the equation number 1, L equals to 2p minus 4. Okay, so in this case, what's about the L? 5 with us. What's about the P? Again 5 with us. Try to solve this one. We can get 5 equals to 6. So in this case, the right hand side is greater than left hand side. Okay, so from equation 2, J equals to 3 by 2 into L minus 2. In this way, we can get the relation. Substitute the value of number of joint, then number of links. Okay, so in this case also, we can get 5 equals to 5.5. In this case also, we can get LHS side is less than RHS side. Okay, since the arrangement of 5 links as shown in figure does not satisfy the equations, and the left hand side is less than the right hand side. Okay, therefore it is not a kinematic chain. Such type of the chain is called unconstrained chain. Okay, that is the relative motion is not completely constrained. This type of the chain is of little practical importance. Now let us see here once again. Unconstrained chain means here, if you just give the input motion for this one, any link, if I give the input motion for this one, AE, so definite actually motion is not occur for the other links. For this one, ED, then DC, okay, then BC, etc. Okay, so this is the case of unconstrained chain. Here the constraints are not given or restrictions are not given. The motion of this BC is not depends upon this one. Okay, so whatever the input motion given to this one AE link is not actually transferred to this one DC. Okay, this is the case of unconstrained chain. Now let us discuss with the types of joints in a chain. The following types of the joints are usually found in a chain. First one, binary joint. Next one, ternary joint. Okay, next one, quaternary joint. Okay, let us discuss one by one. The first one is nothing but the binary joint. Name itself indicate that the two links are joined together at a same connection. The joint is known as binary joint. For example, a chain as shown here has 4 links and 4 binary joints at A, B, C, D. So here, if you look towards this one, A, this one, AB, this indicate the link number 1, BC indicate the link number 2, CD indicate the link number 3, next one, AD indicate the link number 4. So joint between this one, joint this indicate joint between link number 1 and 4 is nothing but the binary joint, because the two links connected at a single point. Here is the same case, this link and this link connected at a single point, okay, or a single joint. This link and this link connected at a single joint. The two links are connected at a point. This is the case of binary joint. Let us check whether this one has kinematic chain or unconstrained chain. Okay, so in order to determine the nature of chain, that is whether the chain is lock chain or kinematic chain or unconstrained chain. The following relation between the number of links and the number of binary joints as given by Kelvin may be used. Okay, so J plus H by 2 equals to 3 by 2 into L minus 2, where J is nothing but the number of binary joints, H indicates the number of higher pairs, and L indicates the number of links. So when H equals to 0, so why we are saying the H equals to 0 here? So in this case, the higher pairs are 0. So the equation 1 may be written as J equals to 3 by 2 into L minus 2. So applying this equation to a chain as shown in this figure, okay? So where L equals to 4, number of joints with us 4. L equals to 4 means number of links 1, 4. Okay, number of joints 1, 2, 3, and 4. So in this way, we can get the number of joints equals to 4. So apply this or substitute the value of this one number of joints and number of links here. Okay, we can get 4 equals to 4. The straightforward meaning for this one, the left hand side is equals to right hand side. Therefore, the chain is kinematic chain or constrained chain. Okay. Next case is nothing but the ternary joint. Ternary means here when the three links are joined at the same connection. Look towards this one. The three connections, three links are connected at a single joint. Same case is here. Three links are connected at a single joint. Okay. Then it is known as ternary joint. So it is the equivalent to two binary joints, as one of three links joined carry the pin for the other two links. The same pin is used by these three links. That's why one ternary joint is equivalent with the two binary joints. Okay. Then we just look towards this example. Okay. So in this example, how many number of links with us? Number 1 is here, second one is here, third one is here, fourth one is here, and sixth one here. So number of links with us 6. It has three binary joints. So this here binary joint formed by link number 1 and link number 6. Link number 1 and link number 2 form a second binary link. Link number 3 and link number 4 form next or third binary link. So apart from this one, link number 2, 3, 5 at point C form the first ternary joint, and this one link number 4, link number 5, and link number 6 form the second ternary joint. Okay, in this case you can get the number of joints with the help of this relation. Okay, so three binary joints with us 1, 2, and 3. So here you can write this way: three binary joints plus two ternary joint, and as it is equivalent to 2, that's why the 2 multiplied by 2 is written here. Okay, so 3 plus 2 multiplied by 2 equals to 7. Okay, so let us now determine whether this chain is kinematic chain or not. For that, we know the number of links 6 with us and number of joints. Okay, so already we get here number of joints equals to 7. Okay, so it is very important to identify that ternary binary joints. Okay, after that you need to convert that ternary joint into equivalent binary joints. Okay, so remember that one ternary joint is equal to two binary joints. Okay, so as per information with us, number of links with us 6 and number of this one joints with us 7. So right here relation J equals to 3 by 2 into L minus 2 in this way. What's about the number of joints with us? 7 equals to 3 by 2 multiplied by number of links with us 6 minus 2. 7 equals to 7. So what's about the meaning for this one? Since the left hand side is equals to right hand side, therefore the chain as shown in this figure is kinematic chain or constrained chain. Let us see the next case, that is quaternary joint. When the four links are joined at a same connection, the joint is called quaternary joint. Now look towards this case. 1, 2, 3, 4. Four links are connected at a single joint. Okay, this is known as quaternary joint. Okay, so and it is equivalent to three binary joints. In general, when L number of links are joined at the same connection, the joint is equivalent to L minus 1 binary joints. Okay, here do you, when we count the number of joints, okay, from this one. For example, consider a chain having 11 links. Here the total number of links available in this mechanism, 11 links. Okay, so it has one binary joint. Just try to identify binary joints, ternary joints and quaternary joints, okay, so that we can get the number of joints clearly from this mechanism, at the same time from this mechanism also, but initially just focus on this mechanism. Okay, so since one binary joint, okay, available here, and apart from this one, just count the ternary joint as well as quaternary joint. Okay, so here one binary joint at D available here. So apart from this one, the four ternary joints at point A, B and F with us. Okay, so at point C and at point G. Okay, so these are nothing but the quaternary joints. Okay, since one binary joint is equivalent to two binary joints and one ternary joint is equal to two binary joints, therefore the total number of binary joints in a chain as shown in figure A R can be calculated in this way. So one binary joint with us plus four formation written, four ternary joints. Okay, and it is equivalent to two quaternary as one binary joint at point D, one binary joint at point D. Okay, plus next one four quaternary, sorry, four ternary joints. Okay, so four ternary joints, and we know the ternary joints is equal to two, this one equal to two binary joints. That's why here the 4 multiplied by 2 is written, plus next one as far as concerned with the quaternary joints, just see, look to us here and here, quaternary joints with us. So in case of quaternary joints, one quaternary joint is equivalent to binary joint. Okay, so here 2 with us, so 2 multiplied by 3. So count the one, calculate this one, 1 plus 4 multiplied by 2 plus 2 multiplied by 3, get the total number of joints. Okay, as far as concerned with first diagram, we can get the 15 total number of joints. Okay, so let us now determine whether the chain as shown in figure A is kinematic chain or not. Okay, so first of all, get the information regarding the number of links. Number of links already, the number for every link is given here. The total number of links with us 11, and number of joints also with us here 15 after calculation, after doing the analysis regarding the binary, ternary and quaternary joints. Okay, so apply this relation, j equals to 3 by 2 into L minus. Okay, so we know the number of joints, we know the number of links. Okay, now just see here case 15 equals to 15.5. Here LHS is greater than RHS. The left hand side is greater than the right hand side. Therefore, the chain as shown in figure is not a kinematic chain. So in previous article already I discussed, this is the case related with the block chain, or this will form a rigid structure, a rigid frame or structure. Whenever the LHS is found greater than RHS, okay, that is the case of blockchain. So already as seen here, case of triangle. Okay, so here we the condition LHS is greater than RHS. Meaning is here blockchain. Now we just see the next case. Next case, first of all, count the number of links: 1, 3, 4, 5. Here the 6, 7, 8, 9 and 10. You may give the number, or you may give the number for any link, okay, in any order. Okay, you can give the number for this link as 1, this one as 2, this one as 3, this way order. Okay, so number of links with us 10. Then count the binary joints. Binary joints means where the two links are connected with each other. Here the binary joint with us 1, so only a single binary joint is available. Apart from this one, just try to focus on the ternary joints. Okay, here the 1, 1, 2, 3, 1, 1, then next one 3, then 4, 5 and 6. Got here the 6 ternary joints with us and 1 binary joint. If you look towards this diagram, here the quaternary joint is not available. Okay, just here. Next case, if link CG is removed from this figure P, this link is removed from this one. Okay, and remaining structure is as it is. It has 10 links and has 1 binary joint and 6 ternary joints. Already have seen that 6 ternary joints at various locations: A, B, E, then at F, then E and okay. So get the information regarding the total number of joints. Okay, so binary joint with us 1 and 6 ternary joints with us. So as 6 equivalent to, as 1 ternary joint is equal to 2 binary joint, means you have to multiply by with this 6 ternary joints. So 6 multiplied by 2 plus 1 is nothing but the 13. Okay, so we know this relation, number of joints equals to 3 by 2 into L minus 2. Okay, so number of joints with us 13 equals to 3 by 2 multiplied by number of links with us 10 minus 2. So here in this case, what we get, 13 equals to 13, LHS equals to RHS. Since the left hand side is equal to right hand side, therefore the chain as shown in figure B is kinematic chain or constrained chain. Okay, so let us discuss about the mechanism. When one of the link of kinematic chain is fixed, the chain is known as mechanism. So it may be used for transmitting or transforming motion. For example, engine indicator, typewriter, etc. A mechanism with the 4 links known as simple mechanism, and the mechanism with more than 4 links known as compound mechanism. So here mechanism which consists of 4 links, the simple mechanism, and apart from this one, if the number of links are greater than the 4, then this becomes a compound mechanism, like this one. So in case of mechanism, when one of the link of kinematic chain is fixed, the chain is known as mechanism. It may be used for transmitting or transforming motion. For example, engine indicator, typewriter. A mechanism with the 4 links is known as simple mechanism, and the mechanism with the more than 4 links is known as compound mechanism. Okay. Already we have seen this case with the help of some of the diagrams. Okay, when the mechanism is required to transmit the power or to do particular type of the work, it then becomes a machine. In such cases, the various links or elements have to be designed to withstand the forces, both static and kinetic, safely. A little consideration will show that a mechanism may be regarded as a machine in which each part is reduced to the simplest form to transmit required motion. As far as concerned with this mechanism, only we have to remember that when one of the link of kinematic chain is fixed, then this becomes a mechanism. Okay, so we have started our journey from the link. Okay, so link, then pair, then next one is nothing but the chain, and last one is nothing but here mechanism. Okay, so in case of mechanism, when one of the link of the chain is fixed, okay, that becomes a mechanism. Thank you. I hope that whatever the portion we have covered in today's lecture clear to you.